Good day everyone. Welcome to my channel Quick Tech Master Mariner. Don't forget to like, subscribe and press the bell icon to get notification of all other videos.
Navigating the seas, magnetic versus gyro compass. Let's dive right into this explainer and look at the fascinating, honestly pretty incredible technology that keeps massive vessels on course. When you're looking out at a totally featureless ocean, it's wild to think about how mariners have confidently charted their paths for centuries and how that tech has evolved to keep us safe today. So, ever wonder how exactly thousands of tons of steel find their way across these massive, completely unbroken stretches of water? Because out there on the open ocean, getting lost is absolutely not an option. They need to know their exact heading down to the second. Section 1. Finding north at sea. Okay, to figure this out, we need to look at how mariners actually define north. Sounds super basic, I know, but north can literally mean two very different things depending on the tool you're using. It all really comes down to two absolute heavyweights in navigation, the traditional magnetic compass and the modern gyro compass. They are wildly different in how they operate, but as we're going to see, they make the ultimate team. First, let's nail down what they're actually aiming at. Magnetic north is our first target. This relies entirely on the Earth's natural magnetic field. It's a localized reading totally dictated by those invisible magnetic forces wrapping around the planet. Then, on the totally opposite side of the spectrum, we have true north. Unlike its magnetic cousin, true north is a fixed geographic reality. It points straight to the geographic top of the globe, zero magnetic sway whatsoever. That distinction is a real game changer. Section 2. The magnetic compass. Let's check out our first tool and see how it holds up in a harsh ocean environment. So, the magnetic compass. It points to magnetic north, using just the Earth's magnetic field. No tricks, no tech. The coolest part? Its rugged simplicity. It operates totally independently of anything modern. We're talking zero power required. The ultimate survivor. Think about it. If a ship completely loses its engines, its generators, every single electrical system goes dark, this little compass just keeps right on pointing. But, well, there's always a catch, right? That reliance on magnetism is also its biggest vulnerability. The ship itself, the massive steel hull, the heavy cargo, it all interferes with the magnetic reading. It constantly pulls the compass off its natural heading, which means the crew has to constantly step in and apply mathematical corrections. It definitely needs active human oversight. Section 3. The gyro compass. Now, let's pivot to the high-tech powerhouse of the modern ship's bridge. Enter the gyro compass. This thing relies on a completely different physics concept, the gyroscopic principle. It completely bypasses magnetism, locks dead onto true north, and literally ignores the ship's steel hull and whatever magnetic cargo is sitting down in the hold. Because it finds that mathematically pure true north without a single drop of magnetic error, it essentially becomes the brain of the ship. It actively feeds flawless directional data out to all the other automated bridge systems that keep the vessel perfectly on track. But all that high-tech perfection definitely comes at a cost. It's totally dependent on a constant power source to keep that gyroscope spinning. Plus, it needs a warm-up period. You can't just flip a switch and instantly know where you are. It takes time and juice before it's ready to work. Section 4. Head-to-head compass comparison. Let's put these two navigational titans in the ring together and see how they stack up. The most glaring difference? Power reliance. Like we just talked about, one is a totally self-sufficient survivor needing absolutely zero power, while the other is completely demanding, requiring a constant electrical feed just to function. And accuracy-wise, they're opposites again. The gyro gives you that pristine, error-free true north. The magnetic compass, though, it demands constant manual correction just to deal with the localized interference from the ship itself. So putting it all together, they are practically exact opposites. You've got the instant startup of the magnetic versus the warm-up time of the gyro. A standalone, unpowered tool versus a high-tech hub that feeds an entire ecosystem. Earth's natural magnetism versus the gyroscopic principle. Section 5, the ultimate navigational duo. Which brings us to the biggest takeaway of this entire explainer, how they actually work together. Picture this. Worst-case scenario. Middle of a massive storm, and the ship suffers a complete blackout. No power whatsoever. Suddenly, that high-tech, incredibly precise gyro compass instantly turns into a heavy, useless piece of metal. And that right there is exactly why the magnetic compass is classified as a mandatory backup. It's an absolute, non-negotiable requirement for every ship, precisely because it doesn't need a single spark of electricity to do its job. It really is a perfect partnership. Modern mariners absolutely need the gyro compass running the complex, automated bridge with pinpoint true north accuracy, but they completely depend on that simple, unpowered magnetic compass silently standing guard as the ultimate failsafe. It's honestly fascinating. Even with all our massive tech advancements, we are still so deeply reliant on a tool that just uses the Earth's natural magnetism. Will high-tech solutions ever truly outgrow the need for the simplest, most reliable forces of nature? Definitely something to chew on the next time you're looking out at the open water.